Hi everyone. This is going to be your pre-lab lecture for recrystallization and melting point. I am not sharing my screen right now because I want to make some announcements because I've been getting a lot of emails about this. So it's mostly about quizzes and I just want to go over it and how we're going to do them, and also about lectures because I feel like that's not a point that has been completely been made. So about your quizzes. So every single quiz is going to be due before our lab day. So our lab day includes online and our lab day includes in person. With the exception of if you're online, you're not going to have a Zoom meeting, you're just going to have a pre-recorded lecture, which means that you can watch the pre-recorded lecture whenever you want, but you need to make sure that your quiz is still done before our lab day meets. So it has to be done before Wednesday at 8 in the morning, no matter if you watched the pre-recorded lecture or if you didn't. I can't really check if you watched the lecture or not. So I'm just trusting you guys. You're going to watch it. Also, for those of you who are doing it online, I can't really see if you guys did your pre-lab notebooks either. I can just trust that you're going to turn in the final complete notebook on Sunday. So I advise you guys to just time yourself, because at the very beginning, it can feel very overwhelming with all the lab reports that you have to be doing every single week. But I promise it's going to go by super fast. And you're going to write them super fast as well once you start getting used to it. But meanwhile, please time yourself. That way you don't procrastinate and leave everything until Sunday. Okay, so that's for quizzes. Now, if you are in person coming for the TLC lab, make sure that your quiz, like I said, it has to be done before Wednesday at 8 in the morning. Now, for you guys do have to bring your pre-lab notebooks to class. This means that they have to be printed. I have to be able to see them, and you need to have every single information there, because if you guys don't, I will send you back because it will be incomplete. It will break my heart to send you guys back, but it's my job and I have to do it. So please make sure you have everything, and that is pretty much it that you have to come into lab. Make sure your quizzes are done, and make sure that your pre-lab notebook is done. Like I said, online, I can't see, but I just have to trust you guys. I didn't really want to do Zoom meetings because I was going to cut into everyone's time, and everybody has a set schedule, so I didn't really want to do that. So we're just going to stick to this for now to see how it works. Now, I do want to set up office hours, so I'll probably be sending a poll to see when is the best time. So that's pretty much all the announcements I have. Let me share my screen. Alrighty, guys, let me show you. Okay, so when you open up the Canvas site, this is what you should be seeing for recrystallization and melting point. As a reminder, this is a complete online lab, so group A and B and C are going to be doing it online, with the exception of A and B switching between weeks. So week of 14th through 18th, group B will be doing this lab. Week of 21st through 25th, group A is going to be doing this lab. Okay, so before your lab day, make sure you read the lab manual, annotate it, get as much as you can from it. This lecture I'm doing is going to go over the major concepts that you should know. It is a hint to labs, it is a hint to your finals, so make sure you just pay attention to it, and it's just going to emphasize the main concepts. Okay, after you read it, make sure you watch these videos that are already posted. This one just goes over like the procedure of recrystallization, and this one goes over melting point. Okay, so like I said, your pre-lab notebook, I can't really check if you guys did it or not, so I just have to trust. And then your pre-lab quiz, that one is going to be due before Wednesday at 8 a.m. Now, I took a glance at the quiz, so I am giving you guys a hint. Your pre-lab quiz is composed of half TLC and half recrystallization. That means that I don't want you guys to panic when you see the quiz and you're like, oh my God, I didn't study TLC. So please make sure you go over TLC, either watch the video I'm going to post for TLC or read over TLC. Honestly, TLC is lengthy, but if you guys want 100 on that quiz, read over TLC. I'm giving you guys the hint. It's going to be both topics. So just make sure you go over both labs. That way you don't panic when you see the quiz. Alrighty, so this is just giving you the dates. So Group C and Group B are going to be doing this for this week, which is the 14th through 18th. And Group A is going to be until September 21st through 25th. As a reminder, after lab, your post-lab notebook is going to be due on Sunday at 11:59. So don't forget that. And then this is the data you guys are going to be using. Everyone is using the same. It's just listed by name. So wherever your name is at, you're going to use all the data that is to your right. Okay, I will show you guys that as well. Let me just make sure I get you guys a presentation. And like I said, this is just going to emphasize some topics that I really want you guys to know and that I feel are very important, and I don't want you guys to miss them. And many of these points are on the quiz as well, so yeah. Okay, so recrystallization is a fundamental purification technique used for organic solids. We use this to obtain clean, pure products, and it utilizes different solubility of solutes in a solvent. Basically what happens is that crystals are grown slowly and only identical molecules are incorporated into the crystal lattice. Impurities which don't fit into the crystal lattice remain in solution, and we can then remove them with filtration. A pure compound, this is what we want out of this lab. It's a homogeneous sample consisting only of molecules having the same structure, and this is going to be what is inside the crystal lattice. Remember, impurities outside in solution. Solubility, super important, super tested on. Most compounds are significantly more soluble in hot solvents than in cold ones. So we're going to use a hot solvent, and the hot solvent is going to dissolve the compound to be purified. Afterwards, cooling is going to happen and it's going to create a crystal lattice and separate impurities. The rate of cooling is super important. I'm going to go over that in the next slide, but just make sure you know that as well. After the cooling occurs and the crystal lattice is formed, the impurities will remain in the solution outside of it. Cooling. If cooling is done slowly, pure crystals of the compound will form, leaving the impurities outside. But if it's done too fast, the impurities can become trapped in the precipitating solid along with the product, and we do not want this. We want the impurities to be separated from our pure compound. Solvent selection. There are many solvents used in chemistry, so picking the right one is crucial. Hence, the ideal solvent for recrystallization is one that the compound to be crystallized is soluble in at high temperatures. This means that it can dissolve to get rid of impurities. However, it should be insoluble in at lower temperatures. This will allow impurities to be left out and for us to get a pure product. Okay, so I just added the slide. That way you guys know that water is going to be our proper solvent to produce solid benzoic acid at 20 degrees Celsius. You can find this chart on your lab manual as well, but I just wanted to show you guys. Melting point. The melting temperature of a compound is the temperature at which changes from a solid to a liquid. Finding an exact melting point is difficult because a dynamic equilibrium is established where a substance is in both solid and liquid form, so we can't really pinpoint a temperature value, so we use a temperature range. Depending on how big your temperature range, you're going to determine if it's pure or not. I'm going to show you guys kind of a rule of thumb to check for purity with temperature ranges in a little bit. Melting points, like I said, can help determine the purity of a substance. The Vernier melt station is used to determine the melting temperature of recrystallized benzoic acid sample, known and unknown samples. This is very different from your online lab, so I'm going to explain that a little bit, how we did it in lab before and how it's done now, because it is a little bit different now that every single data point is given to you, and back then we would have to find the data. So I'm going to explain that because it's a little bit confusing, but I'll do that at the very end. Okay. Oops. Okay, this is your rule of thumb to determine if your sample is pure or not. So impure samples display a decreased melting point, and the melting point range is typically much larger. So if you see that a melting point range is very large to what it should be, then you can automatically know that it is an impure sample. Okay. As sample melts, the system becomes more disordered and less favorable. The eutectic point is the equilibrium point at which A and B melt in a constant ratio. Make sure that you know this definition for quizzes and for tests. Right here, this is your eutectic point. And your eutectic mixture is not pure. That's all you have to know. Okay, so for this experiment, we're going to be calculating percent recovery and not percent yield. So percent recovery is done by mass after crystallization divided by initial mass times 100%. Okay, I think that's very end of the PowerPoint, so let me pull up the data. Oops. All right. Now, whatever, sorry, your name, you're gonna look for your name, and under your name, you're going to find the values that you're going to be using. So for the percent recovery, like I said, you need to include this in your conclusion to explain your results from your post lab calculations. Now, I do want you guys to include this in your pre-lab calculations. So just like it's written right here, you can just add it, and afterwards you're going to input your numbers. You're going to be putting that in your post-lab calculations. Remember, post-lab calculations are part of your data. And then you're going to explain your percent recovery in your conclusions. And you can just explain why you got it, why you think it was so low, why you think it was so high. Like I said, I'll show you this. So you're going to get your sample, which is going to be at the very bottom. And then after you're going to get your product, you're going to put your product at the top, you're going to divide, and then you're just going to multiply by 100. Okay, this is a little bit tricky to explain, so bear with me. Like I said, if you guys have questions, just go ahead and ask me afterwards. Okay, so in your lab manual, you're going to get this little chart right here. And it says potential samples for melting point determination. Now, if you guys were in lab doing this, you guys would determine the melting point range for all of these, but you guys are not, so you guys will have to use the internet to find these. After you guys find the melting temperature ranges for the ones listed in your lab manual, which are these, you're going to compare these to your unknowns. If you think benzamide matches, let's say, with unknown 2, then you're going to put that in your conclusion. I believe benzamide matches with unknown 2 because, or if your melting point range temperature is huge, then you can say, okay, I believe this is impure, and you're going to explain why you believe it's impure. Now, this melting point for benzoic acid is the pure benzoic acid. So you can definitely compare this one to one of your unknowns if you believe it's closest to it. Let me just make sure. I kept all of my labs, so I keep referring to these. Yes, so you're just going to compare them to your unknowns are going to be compared to the potential samples. And like I said, you need to look for these samples online because they're not given to you. So just make sure you do that and you compare them to your unknowns. And after that, you should be good. Remember to put your percent recovery, match your unknowns to the potential samples that are given right here. Remember, you have to look for these online and then match them to your unknowns. The melting point for benzoic acid, that is pure. So you can definitely use this to compare them. Now, if you notice that one of the unknowns is close to 1, but the temperature range is huge, make sure you note that too on your conclusion. Also explain how melting point and recrystallization is used, mention any errors that might have happened, and that would be it for your conclusion. Don't forget to do your data analysis, which is at the very end of your lab manual. Actually, I can just show you. Oh, and like I said, if you guys want to copy these tables, you can. Remember that these are given to you. So you can just put the ones that they were given to you in the Excel sheet and just plug them into here. And like I said, compare them to what they actually would be. And then this is your data analysis. So make sure you get this one done too. And you can just add it in the same Word document. That's completely fine. But that is basically it. Now, for your post-op calculations, make sure you only put the percent recovery because you're not really doing anything with these. There's no math involved or anything like that. The only math involved is for this part. So as long as you have these two tables and you show your post-lab calculations to determine the percent recovery, you should be completely fine. And just make sure you explain the two tables and you explain your percent recovery. And that would be it for your conclusion, like I said. If you guys have any questions about this lab, if you guys still don't understand something, let me know. But other than that, that is it for this experiment. If after watching this video, like I said, have a question, send it to GroupMe. I reply super fast. I'm always on my phone and I'm always on my computer, so I reply super fast. So yeah, I hope you guys are having a great day, and I'll see you for TLC.